All right, guys, the next part of this 2-day lesson is going to talk about deriving the area of a regular polygon. So I'm really sad that we can't do this one in person because this is a really awesome activity, but hopefully on your formative from Tuesday, you guys kind of gave some guesses on how we could derive this area of a regular polygon. So I'm going to go ahead and show you guys how we can do it, and I'm going to take a look at this left figure first. So when you guys are looking at this, what you can think about is if I have the center of this polygon and I were to create radii to each of my vertices. Hopefully you guys see that this is creating 5 different triangles. And one thing that you guys can know from these 5 different triangles is that I know this base of each one is the same. And I know that each one of these interior lengths is also the same because they're all that radius of the figure. So right now I have 5 congruent triangles that I've created inside of this polygon. So if I wanted to find the area of this polygon, I could find the area of each triangle and add it together, or the area of one of the triangles and multiply it by 5. Well, in order to do that, what I'm going to need is I'm going to need to know what my side length is, and I'm going to need to know what my height is. Well, the height of this triangle is a segment from the center perpendicular to one of my bases. And if we remember from yesterday, this is what we also call our apothem. So what I can do to find the area of this polygon is I can find the area of one of my triangles. The area of one triangle, that's going to be 1/2 base times height. But instead of base, I'm going to put my side length. And instead of height, I want to put my apothem. So area of one of these triangles here is 1/2 the side length times the apothem. And if I wanted to find the area of the polygon, I want to do this area of my triangle, so my 1/2 side length times apothem, and I want to multiply that by the number of triangles that I have. And I'm going to just put a little thing out here where n is the number of triangles or side lengths. All right, so one thing that I do want you guys to notice here is I have my side length times my number of sides. And if you guys think about it, isn't my side length times my number of sides the same as the perimeter? So instead of saying the number of sides times my side length, I could shorten this a little bit and say that I have 1/2 my apothem times the perimeter of my shape. So this is how we find the area of any regular polygon. I can just do 1/2 my apothem times my perimeter. All right, so let's go ahead and try a couple of examples. I actually want to start with example, let's start with example 2 because I think this one is just a little bit more straightforward than the other one. So I have a regular polygon with an apothem of 2 feet. Or I'm sorry, a regular pentagon. So pentagon, what that means is, and we can count this too, I have 5 sides. So if I have an apothem, I need to draw in the center and that segment perpendicular. And I know that this is 2 feet. All right, so to find the area of my regular polygon, I need 1/2 the apothem times the perimeter. Well, right now, I don't know what the perimeter of my shape is, so that's something I'm going to have to find. But if you guys look here, I can create a right triangle so that I can find part of one of my side lengths. And since this is, since all of my triangles are going to be isosceles here, I know that if I find one part, I know that my other part is also going to be x. So let's see, how can I do that? Well, I don't have enough sides to find it using Pythagorean theorem. So what I can do is I can use that idea of my central angle. So I can find this angle here and use that to find the measure of the smaller angle of my right triangle. So since this is a pentagon, I know that I could find that central angle by doing 360 divided by my number of sides. So that means that my central angle is 72 degrees. So this whole thing is 72 degrees. And if I wanted just one part of it, I can do my 72 degrees divided by 2 and find that this angle here is going to be 36 degrees. Now, and I'm going to draw this off to the side so we can see it a little bit better. Now I have a right triangle with one side length of x, one side length of 2, and a degree of 36. So in order to find x, I can use my trig functions. So I can do, if I'm looking here, I have my opposite. I have my hypotenuse is opposite of my 90 degrees. And my adjacent is the leftover. So in this triangle, I have my opposite and my adjacent. So thinking back to my SOHCAHTOA, that would be tangent. So I could take the tangent of 36 equals opposite over adjacent. I can do cross products, so I get that x equals 2 times the tangent of 36. So x is approximately 1.5. So looking back at my polygon, x is just this short length right here is 1.5. So the whole side length would be double that. So we're going to have 3. So 3 feet is my side length. So if I wanted to find the perimeter now, my perimeter I could just do, and I'm going to write this in a different color. My perimeter is going to be 3 feet times my number of sides with it, which is 5. So my perimeter is 15 feet. All right, so going back to my area, now I have my apothem and my perimeter. I can say the area is 1/2 2 times 15. So my area is 15 feet squared. So I know this is a lot, but we are kind of combining all of those different ideas together, combining that idea of trig, finding those central angles, and those new definitions. So let's go up, let's try another one. A regular hexagon with a radius of 10 inches. So I'm going to draw my radius. So I have a center, and I'm going out to one of my vertices. And I know that this is 10 inches. And so now I want to kind of draw in one of those triangles that I'm going to be finding the area of. And I have my apothem is going to be going perpendicular. So now I'm going to need to find both my apothem and my perimeter before I can solve this one. So what I need to do is I know that I have this side length here of 10 inches because this is another one of the radii that I have. So let's figure out what are these missing angles on the top here and the bottom here. And so remember, we have two ways to find angles. So we can find this angle here, so one of my interior angles, using my 180 times n minus 2 divided by n. Or I can find the central angle, doing 360 divided by my number of sides. So I'm just going to show you guys the way we didn't do on the last problem. So I am going to find the interior angle measure. So on this one I have a hexagon, and a hexagon has 6 sides. So I'm going to substitute in 6 for my n. So 180 times 6 minus 2 divided by 2. So one of my interior angles is 120 degrees. So that means the whole angle here is 120 degrees. So if I wanted to find just this smaller angle, that's going to be half. So this angle is going to be a 60-degree angle. Well, now what I'm looking at is I'm looking at a right triangle with one angle being 60. So I know my other angle has to be 30 degrees. And I have a hypotenuse of 10. So right now, hopefully you guys notice, now I have a 30, 60, 90 triangle. And I can use my ratios to find the other two side lengths. So 30, 60, 90, I have 1, 2, root 3. So I have a 1, a 2, and a square root 3 side. Well, if 10 is my 2, that means the bottom is going to be 5, and the apothem, or the height here, is going to be 5 root 3. So I have a 5 root 3. So if I know this one small part of my side is 5, I know the whole thing is going to be 10. So my perimeter, I can just do my number of sides, which is 6, times my side length, which is 10. So my perimeter is going to be 60 inches. And my apothem, we found, is 5 root 3, using my 30, 60, 90 triangle. So my area is 1/2 my apothem times my perimeter. And when I substitute those values in, I can get that my area is exactly 60 times 5 divided by 2. So that's going to be 150√3 inches squared. Or if I wanted to approximate it, that would be 259.8 inches squared. All right, let's try one more together, and then I will let you guys practice, and I will add a ton of practice and a couple more videos so that we can see, so you guys can watch a few more if you would like. So a regular nonagon, so this word nonagon means that I have 9 sides with a perimeter of 144 inches. So what that means is I just have to find my apothem here, because I know my area is 1/2 the apothem times the perimeter. So if I know my perimeter is 144 inches, so the perimeter equals 144 inches, then one side is going to be 144 divided by my number of sides. So one side length is going to be 16 inches. So I'm going to go ahead and label that in my picture. So if I draw the apothem in here, I know I have a side length of 16. So when I draw in that triangle that I'm going to need to use to find my apothem, I know that the length from my apothem to the vertex is going to be 8 because it's half of the length of my side. All right, so I'm looking for my apothem, and all I know is that one of my side lengths is 16. So what I can do is I can find this angle measure here, and I'm going to call it angle 1. So the measure of angle 1, I could do 360 divided by my number of sides, which is 9. And then that'll give me the whole angle measure here, so the big angle. So I'm going to have to divide it by 2. Oops. Divide it by 2 to get the measure of angle 1. And when I do that, I find that the measure of angle 1 is 20 degrees. Now I have a right triangle here. I'm looking for my apothem. I know I have an angle measure of 20 degrees. And I know I have one of the sides of this right triangle is 8. So now I can use my trig functions again. And here I have opposite and I have my adjacent. So that's going to be my tangent function. So the tangent of 20 is opposite over adjacent. I do my cross products and I get A times the tangent of 20 equals 8. And if I divide both sides by the tangent of 20, I get that A is approximately 22 inches. Perfect. So now I found my apothem to be 22 inches. So plugging back into my area formula, I get the area is 1/2 22 times 144. So my area is 1,584 inches squared. All right, that is all for this video here. go ahead and go practice some more.